Hello, this is Max Zamanian. You can write my name here, Max Zamanian. I'm PhD in economics and finance. I'm going to put up some videos about in the area of macroeconomics, mostly how you can solve simple exercises in this area, and also the same kind of issues, videos for solving problems in corporate finance and so on. And maybe also I'm going to have some videos regarding simple mathematical problems that you need in economics and finance, mathematics, and maybe also statistics. But for now, there is a simple problem in basic macroeconomics. It's called ISLM example. Of course, these videos are intended for students who has taken the course and know what ISLM stands for. So I'm not going to go through the theoretical presentation of these issues, just simple solution for typical problems in the area. So a typical problem in the area of ISLM is that, like this, you have the information of how the goods markets are. This is consumption function, tax function, import function, investment function, the amount of government expenditure and export. And here the notation is that investment is a function of interest rate, and that actually makes the problem of IS and LM. Also, you have the money markets information. This is money supply, is fixed and decided by the central banks normally. And this is the money demand, which is a function of income and a function of interest rate. So we're going to show how you can drive the so-called IS function from the goods market and LM function from the money markets. Task normally is like this. Among other, the task is to drive the equilibrium national income, which is Y, and equilibrium interest rate. That means when the goods market and money market both are in equilibrium, you are going to get equilibrium Y and equilibrium interest rate. The graph could be like this. You have national income in the horizontal axis, and you have interest rate in the vertical axis, and typically IS curve is negatively sloped and LM curve is positively sloped, and point of intersection of these two curves will give you the equilibrium national income and equilibrium interest rate. So what we are going to do is first to drive this function and then drive this function, both of them represented by equations, and then when you are going to have two equations, and using these two equations to solve the point of intersection, means that when these two equations have the same point for y and r respectively. All right, we can start by driving is function here, and we use to drive is function. You can set the equilibrium condition for the goods market, which is national income equal to planned expenditure, which includes consumption, and it includes investment, government expenditure, plus export minus import. This is the equilibrium condition. Next, we can insert the consumption function from above here instead of C. So we have 10 plus 0.8 times y minus t. The investment function from here is 5 minus 8r interest rate plus government expenditure plus export minus import, but instead of import we can insert the import function, which is 0.2 y. Now the idea is that to isolate all functions with y on the left hand side and those with r on the right hand side, then you will have a function of y, the function for y of r is what you get. Here we have taxes, so we can insert the tax function here from here. So you get rid of t, and instead you will have y. So now we can do some algebra to get a clean and nice is function. We can start to get rid of these parentheses, all parentheses. So I rewrite the function again using 10 here plus 0.8 times y. So I have this term. Then I have minus 0.8 times 0.3. It's 0.24. Y, and then I have 5 minus 8r plus 38 plus 20 and minus 0.2y. So I put together all these constant single numbers first. 10, 15, 23. I can do it in my calculator so you can see how it is. 5 plus sorry, I can put all these constants first, so I just add them together. 10 plus 5 plus 38 plus 20 is equal to 73. Then I can add together terms including y. To add these together, you just add these coefficient first. So 0.8 minus 0.24 minus 0.20 equal to plus 0.36, and then you put y. So we have handled all these terms. What we have left is this one. We put just 8r here. Now I want to get this to the left. So the practice is that you change the sign when you transfer one term from right hand side of the equation to the left hand side of the equation. So what I'm going to have here on the left hand side is the y that I had in the beginning minus 0.36 equal to 73 minus 8r. And from this I will have 1 minus 0.36 equal to 0.64 y equal to 73 minus 8r. So if I divide all terms with this 0.64, then I isolate r here, because 0.64 divided by 0.64 is like 1. So it's a 1 time y. I don't need to write a 1. So I have only y here. Here I have 73 divided by 64. 73 divided by 0.64. That makes 114. I skip the decimals. and minus 8 divided by 0.64. I have 12.5 times R. This is my IS function. All right. Next, we want to derive the LM function. We use the equilibrium condition for the money market, that is money supply equal to money demand. And we replace these money supply and money demand with the right hand side for each of them that we have got here. So we have 80 equal to 80 equal to the right hand side of money demand, 40 plus 0.4 y minus 80 r. In the same manner as before, we want to have y on the left hand side and the constants and the r on the right hand side. So I keep this actually on this side, write 8.4 y and I move this to the left hand side. I change the sign, but here 80 in the same side, to drive the LM function. We set the equilibrium condition for money market, where money demand is equal to money supply. We can write the right hand side of this equation. First, money demand, 40 plus 0.4 y minus 80 r. Then money supply, right hand side, it's 80. Again, we try to isolate the term with y on the left hand side and all other terms with constant and including r on the right hand side. So I have 0.4 y on the left hand side. On the right hand side I already have 40. I move 80, I'm sorry. I move 40 to the right hand side. I change the sign. Also I move this term minus 80r to the right hand side. I need to change the sign from minus to plus. All right. I rewrite this and then add these two together. 80 minus 40 is 40 and plus 80r. Same as before, to get y isolated, I need to divide all terms by the coefficient for y on the left hand side. So 0.04 divided by 0.04 makes 1, so I get rid of it. I have only y here. And then I divide on the right hand side both terms with 0.4. Let's see what I get here. 100 plus 80 divided by 0.4, 200 R. And this is actually the LM function. So we have these two functions, IS, LM, and to find these 2 points, these intersection points and these two values, we need to use these two equations. And I will do it next page here. I can do it like this. I have these two equations, y equal to 114 minus 12.5 r. Then I have for LM function 100 plus 200 r. By the way, you can see that we have negative here because IS function is negatively sloped. And a plus here, that means LM function is positively sloped. All right, there are many different ways to solve this problem. This is actually in mathematics called a system of linear equations. A system because you have two equations tied to each other and they are linear. There are many ways to solve them, but we use the substitution method. We use the substitution method, and the first step with step 1, set the right hand side of both equation equal to each other. That's what you do in the first step. So right hand side for is function is 114 minus 12.5r equal to right hand side of ln function 100 plus 200r. So solve r, which is the equilibrium. The equilibrium r. All right. I can gather terms with including r on one side, so I start with plus 200r, then add together, I move it to the other side and change the sign, is plus 12.5r. On the opposite side, I have opposite side to this, I have 114. Now I move this to the same side as this one, and I have to change the sign, so I have 100 here. So if I add these two terms, I will have 212.5r, and adding these together means that 114 minus 100, and I have 14. To solve for r, I need to divide both sides with 212.5. So r will be equal to 14 divided by 212.5, and that is interest rate, 0.0, can round it to 0.66. That's the same as saying that interest rate is equal to 6.6%. Okay, and this is the equilibrium interest rate. Well, I don't need this page, I can get rid of this and just move it the whole screen here. In the second step, you insert the equilibrium R in one of the functions above. I choose LM function, seems easier. So y equal to 100 plus 200 r, but instead of r I put the solution for r, which is 0.066. This way I get my equilibrium national output. So I first multiply 200 with 0.066. It's equal to 13.2, then plus 100. So I have y equilibrium equal 113.2. That's actually the end of story. You might be asked to use these numbers, equilibrium output and equilibrium interest rate, to calculate some numbers. For example, to calculate tax and compare tax with government expenditure. Then you can have budget deficit. You might be asked to calculate consumption, then you have national output, equilibrium, and you have tax from here. So you can calculate consumption, you can insert interest rate here to calculate investment, and also you can calculate private saving by setting saving equal to output y minus consumption and minus tax. Okay, thank you for this session. Good luck, and see my other videos in macroeconomics and finance and mathematics. Bye-bye.